So this is a talk about 3D design, and I feel a little bit like a fraud in doing this talk because this is not my day job. This is something I did as part of an open source project called OpenTRV that Damon knows everything about. But there are some. But I want to take you through the process of what this is all about. And this is about a very particular type of 3D design. It's not about designing for games. It's about designing real-life objects that can be printed on a 3D printer. And that has interesting implications. So I will share my screen and you can see what I'm talking about. So share this. Excellent. So when you talk about 3D design, you typically have two types of design packages that allow you to do 3D design. Right, so you basically have two types of 3D design packages. And normally at this point, you should see a different window with a red object spinning in the middle. Is that correct?
Yes.
Okay, excellent. Right. So you typically have two types of 3D packages. You've got the packages that work with meshes, which is basically a mesh of triangular facets that create an object, and that's what you typically use in gaming. That's what Blender does. That's what you have. So the rotating shape here is 3.js. So all those packages use meshes, and basically what they describe is the outside of the shape, and that can lead to some problems. So for example, you can see on the thing that I've got rotating on the screen here that it doesn't have a facet at the bottom or the top. Therefore, it's like a skin, but with a thickness of 0, and that cannot be transformed into a real object. That's not printable because your 3D printer will not know how to create something of width 0 apart from thin air. So the second type of packages are what we call volumetric designers, and that's what a tool like OpenCAD is about. So you should normally see a window with 3 shapes on it. So what does a volumetric 3D designer do? It works with simple volumes and allows you to combine these volumes. So for example, what I've got on the screen here is three very simple volumes: a cube, a sphere, and a cylinder. And that's the primitives, but you can then combine those primitives with what you call Boolean operations. So if we take a union between a cube and a sphere, we get a shape like this. If we take the difference of these two things, we get a shape like that, where you can see that the system has taken out part of the sphere out of the cube, and it's calculated the intersection itself of these two shapes. So that was a difference, but you can also, the final option you have is to create an intersection, which is basically what is covered by both shapes. So and there are pros and cons to this approach. With a volumetric solution like this, you tend to have shapes that are less organic because you have to create them from the ground up with different bits and pieces. But on the other hand, this should always be printable. So you should always be able to create a real object out of this. You can fail this occasionally, but most of the time it's okay. So how did I get involved in doing this? So basically, with the OpenTRV project, what happened is that the whole idea was to create what Damon would call a thermostatic radiator valve. So it's, if you see on the video, it's these small boxes, there's a PCB inside, and it will control your radiator. So when creating the initial version, we basically needed a box to put this in. So so that's what we started doing, and with a 3D designer, it becomes reasonably straightforward to create that sort of shapes, and that can then be 3D printed. So, but you've got a couple of things to take into account. So I'll stop sharing for a second and I'll go on the video. So if you look at a box like this, that's been printed by a 3D printer. And I've got several on my desk, and you can see, well, I don't know if you can really see, but depending, some of them have a different level of quality because of the 3D printer, because of 3D printing. Some printers are well set up, some printers are not that well set up. The other thing you might want to take into account is the fact that someone will have to put them together. So if I unscrew this one, right, if I manage to unscrew this one, should I say, I probably don't have the right screwdriver. The moral of this story is, if you do a talk like this,
live demos, you're killing yourself.
Unscrew one beforehand. Do not.
I have a Rev 2 and a screwdriver, if that's helpful. Bruno, do you want me to take mine apart?
That's, I'll get there.
Okay. All right.
It's just that it's taking a bit.
People didn't know they were signing up for the excitement of a live unboxing.
Well, yeah, live unboxing was not what I was planning to do, so I should have done it beforehand. Right, but I'm there at last. So if you see this, what you got inside there is a PCB with connections. There's a secondary PCB in there with the buttons. So one of the important things in designing these boxes is to actually consider the fact that you will need to put them together at some point, and you will need to insert the PCB in there. So one of the things we did in this instance, and you see that there's an antenna coming out of the box as well. There's all sorts of things happening in this thing. So it was actually built in layers so that you could put it together and fit the PCB correctly in there. So so yeah, that's all the sort of things that you want to take into account when you build that sort of object. Is what is the shape that you're going to have? Then not just this, but how are you going to put it together? You also have to take into account the fact that 3D printers work with laying out melted plastic in layers. And one of the things they struggle to do is to bridge a gap. So if you see on this one, you can see that the little openings here have a lot of filaments in between. That's because the printer didn't bridge the gap very well. So you want to avoid all those things. And that's all part of the design of doing this, of understanding what it is what it is you're going to put in that box, how it's going to be printed, giving it a bit of leeway as well, so that things can move a bit. Right, I'll go back to sharing my screen and go through the rest of it. So at that point, we have a box. Excellent. But what else can we do with, so as you can see, that's very square and not very, well, yeah, that's very square. But what else can you do with that sort of things? So OpenCAD allows you to do things that are slightly more organic. So one of the things, for example, here is the linear extrude. You take a 2D shape and you extrude it linearly, vertically, but you can add a twist in the middle. So that's what I've done here, where you've got a shape that starts as an 8-star thing, and that gets extruded and twisted at the same time. And you can sometimes obtain some very interesting shapes. So if I combine two of them, you start with an 8-pointed star at the bottom, and you've got a 16-pointed star at the top. So you can create some fairly interesting shapes with that. So for those of you who have been to Barcelona, this is actually the shape of the first third of the main pillars of the Sagrada Familia Cathedral. Working with a 3D model like this, so in people like an architect like Antoni Gaudi was doing a lot of this and creating his designs by combining mathematical shape that were quite interesting. The other thing you can do with OpenCAD is a rotate extrude, where basically you take a 2D shape and you extrude it along by rotating it. So you can obtain things like a torus like this one. And eventually you can create some more complex shapes. You can also create shapes like that look a lot more organic by using the same method as a mesh-based designer, where basically you calculate a mesh and you create a shape. So that's what we call that's an hyperbolide, which is a shape used a lot in industry because it's quite strong and it's technically easy to do because it's all straight lines, even if it doesn't look like it. So actually, to show you the straight lines, I'm going to do something here, which may go very wrong. Where is it? Here. Right, I'm just changing the ratio between the top circle here and the middle circle here. So you can see as it grows or expands, basically what happens is that the way this shape is created is by twisting the top circle against the bottom circle, and all the corresponding lines get twisted around, and that gives you this organic shape. This is also the same way that, so that's typical of industrial chimneys and all sorts of things. But so basically, you can also do that sort of shapes. But to show you what it looks inside, if you actually cut it off, that's what it looks inside. So, and that's an interesting aspect of the solid 3D designer, a volumetric 3D designer. I created a shape which is the same shape as the one I showed you earlier with 3.js. So it's the same shape as this one. But the 3D designer here ensured that it was all closed. And when I take a slice out of it, I have a volume in the middle. So that's something that is printable. And or I can take the difference in a different way when I take it away from a slab, which in practice looks like this inside. So you can see the shape here taken out of the slab. Right, I'm going to run out of time. So other things you can do. You can get quite other type of shapes you can do. That's a horn that's created using Bezier curves, because the well, in practice, the SCAD language is like a computer language. And what you can do with a computer language is do things like recursion, which is how the Bezier curves is calculated here. And if you take that horn and you remove another horn out of it, what you get is a drinking vessel, maybe.
I demand a test with beer.
I'll have to print it first.
Well.
And that's what it looks like inside, basically. That's our shapes. So yeah, basically OpenSCAD is a computer language that allows you to describe your shapes and your scene. So and let's have a look a bit more at the code here. So you've got two types of concepts in OpenSCAD. You've got functions and you've got modules. A function is just the same as it would be in any other language. You take parameters, you return a value of some sort, which tends to be a number or an array of numbers. And a module will enable you to define a shape and have it displayed on screen. It allows you to reuse that shape, so which is what I've done for the difference in horn here. I created a big horn and a slightly smaller horn, and I made the difference between the two. But effectively, it's reused the same module. And you can take that to the next degree. So the last piece I wanted to show is this one. If you start with a simple tetrahedron, so that's the simplest. I'll say this. That's the simplest of the irregular solids. So it's got 4 vertices, 4 faces. If anybody of you have ever played Dungeons and Dragons, that's the shape of a 4-sided dice. But I'm using a computer language here. So I could do something a bit more complex. And in practice, that computer language is also a functional language. So it's very well designed for recursion. But I can do recursion with functions, but I can also do recursions with modules. And what you get here is you can create that sort of shapes with not very much code by basically taking the original tetrahedron and then recursively reproducing that shape 4 times, moving it, and you obtain that sort of shapes. So, yeah, you can do some very advanced stuff with that sort of software. You have some limitations with it. So, So in practice, OpenCAD allows you to transform your shape. You can stretch it, you can rotate it, you can do a lot of things, but it's all the transforms it has are affine transforms. So you can't, for example, wrap a shape around another one, because that's not, an affine transform is a transform that conserve parallelism. So if you've got two faces that are parallel to each other, they will be parallel after they are transformed. So if you want to shape something around, say, a cylinder, you can't really do that. So that's about it. And I've got, oh yes, the other sort of things I wanted to say. So what I've showed you here is that's the OpenCAD UI. So you will see that the user interface is split into 3 panes: a pane for the code, a pane where you can see your what you're working on, and a console that gives you an output. What happens next with that sort of tool is you can you see the STL, the export as STL icon on here. That's the next step that would happen. So OpenCAD will create these shapes, and what you do after that is you create, you export it to an STL file. And STL is a standard open source, open data data format that describes 3D shapes, and that is designed for 3D printing. So most 3D printer software, the vast majority, will actually be able to read STL files. And what you do, you export this to STL. The next step is to actually take it through what we call a slicer. And what the slicer does is it transforms the STL file into what you call an object file, which is basically a set of instructions for the 3D printer to go and print the thing, if it can. And that's what the slicer does. But it's called a slicer because basically what it does, it creates the instruction in slices to create your shape. And that's how you create boxes for your hobby electronics project.
Hurrah, thank you. And you did a splendid job. Thank you, Bruno.
Right. Other aspects of this, yeah, obviously when you do this, you've got to talk to the people designing the PCB and make sure that you take into account how they're designing this thing so that it fits into your box. You also want to make sure that you've got the right spec. So, for example, on this version, we had 2 buttons with, and there's a label M and L. We discovered after putting it together that the labels were in the wrong order. But something like a 3D printer allows you very fast iteration of your thing. So if you make a mistake, you can correct it, rebuild your model, and then it's the time to print it. Yeah, it can be a few hours, but it's still a lot quicker than what you would have normally. So it's extremely good to iterate the design quickly when you got a prototype of your project. When you go a bit more mature, you will want to have it done through proper manufacturing processes. And obviously, the other thing is, as we saw with the horn and different things, is it allows you to do not just produce design for electronics, but it allows you to produce all sorts of other things. So have a look at willowcreative.nl. This is a young lady in the Netherlands who uses 3D printers to create costumes or parts of costumes, and she's got the most amazing stuff. Actually, the idea for the horn came from what she does. That's the inspiration I had for the horn. So, oh, and I just realized that I've been saying all this without actually sharing, that part of the screen. So let me share what she does. You can see on her website, there's all sorts of different designs that come from 3D printing. And that's the sort of things that you can do as well with that sort of technologies. Right, so this time I'll really stop sharing and I'll open the floor to questions. Damon, did you have a question?
No, I could show. I've got a Rev 2 which I could show off, which is another one of your designs. Nice to point out you did that layer design really did work, and we did vary it a few times, didn't we?
Yeah, yeah.
And I could show off what the mass-produced version looked like that came out of Shenzhen ultimately as well, if anyone's interested.
I've got one here.
Have you got a Rev 2? Right, fine. You're just trying to stop them seeing the hair, aren't you? Yes, exactly.
Well, it's easier for me to unscrew this thing than give you the ability to present, unfortunately.
Oh yeah, possibly, yes.
So that's the final product which came out of Shenzhen. I've got the Rev 2 as well, so that was the second revision. Here with a big red button, because Damon wanted a big red button, and it's connected to a Raspberry Pi. And actually, you see the Raspberry Pi is in this case, which is built by Pybro, and that's what gave me the inspiration to do the shape for the PCBs in layers like this, so that we could actually build the casing around the PCB.
Well, I might refer to some of those things again when I'm doing the talk next week, and I will probably waive a few of the same things, as many as I can take away with me on holiday sensibly without being shouted at.
Oh yeah, and I saw as well, Damon, that you posted the Thingiverse address.
Yes.
Oh, yes, that was going to be my next thing. If you want to see a lot of great 3D designs that you can use for free, Thingiverse is the place to go. And it's usually STL file, which you can print directly. I don't know if you can open them in OpenCAD, but yeah. Well, no, you probably can't open them in OpenCAD, but you can open them in other 3D packages. Any more questions?
Yeah, I do. So just out of curiosity, have you always wanted to like pursue a career in 3D printing, or did you stumble upon it, you know, while you were trying to go for something else? And then have you always, sorry, my last question is kind of like a series of questions. I thought I just may as well just get it out, you know. Have you always wanted to work in the IT, you know, tech industry, or were you doing something else before and then you made a career switch? If so, how did you get into it?
So that's a question that has multiple, where the answer has multiple parts. So as I mentioned at the beginning, the 3D printing is not my day job. I did it for the OpenTRV project, but in my day job, I basically design software, I build software. But to answer the other part of the question, so the first part is, yes, I've always wanted to work in IT, because I fell into it when I was 14 with a math teacher that showed us, so at the time, it was in the 80s, which shows how old I am, and we had one computer in the school, and the math teacher decided to basically do sessions in the evenings for people who wanted. And I went to it and realized I liked it. In terms of 3D design, yes, I've always been very interested in 3D design. So if we go forward to the 90s, so a bit more recently, my second computer was a Commodore Amiga. And at university, a few of my friends were very much into what you called ray tracing at the time, which is about building 3D designs. And the most popular ray tracing package at the time was called PovRay, and it is a volumetric 3D design package. So it works in exactly the same way as OpenCAD, with the addition that it cares a bit more. It does shapes, but it does also materials, and it's designed for to render things on screen. So I've always had this interest. I've always also been very interested in architecture generally and interesting shapes. And that's why when I went to Barcelona, I spent a full 2 days visiting all the buildings that were built by Gaudi, from Casa Batlló, La Pedrera, La Sagrada Familia. And the reason why I presented some of this in the talk is that while I was there, I actually found a book about how to create some of the shapes in La Sagrada Familia with a CAD system, where they explained how the shapes work. So yes, that's always been an interest of mine, even though I don't really do 3D design as my day job. My day job is about creating web APIs and that sort of things. Does that answer the question?
Yeah, definitely. Yeah, thank you very much.
Any more questions? Jake, you joined late, so do you have any questions on what was said? Or Sonia, I saw you wanted to say something.
Hi, yeah. Thank you for the introduction. That was pretty cool. And yeah, I joined slightly later as well. So apologies if I'm asking a question that's referred to at the beginning. But with the last bit of software that we've seen, you talking about limitations of it. Is that sort of like the best sort of like entry point software that you would recommend us playing around with, or are there other kind of options that we should consider? And also a secondary question to that is I'm interested in also the materials, the outputs that are coming out from that. Can you discuss a little bit about that? Like what are the options in terms of materials, or is there just the one, you know, standard kind of like plasticky thing that we see everywhere and all the time, you know?
Okay, all right. So the software presented, OpenCAD, is an open source piece of software that will run on Windows, Linux, Mac. I find it very good as a first piece of software to get your feet wet in that area, because once you've installed it, it's quite easy to create shapes, and they are because it's designed to build shapes that are designed for printers. It doesn't mess. You don't have to mess with getting the right camera angle, in getting the right lighting and all that sort of things, because it just deals with the shape. On the other hand, it's a programming language, so you've got to learn the programming language, even though it's fairly straightforward. So that might be a difficulty for some people, and it might be easier for others. I mean, for me, because I work in tech, a programming language is the way I think. So that's ideally suited to what I do. So if you already do programming, that fits quite well. If you don't, then maybe a packages. Well, I was going to say Blender, but Blender is more designed for. It's not necessarily.
Awesome. Sorry, I like Blender and Nomad. They're pretty good. But can you actually like 3D print from those? Like,
if you can export to STL, yes, you can. So I don't know these packages well enough to know if they can export to STL.
Okay, cool. Thank you.
Hey, Bruno, on the question about plastics, I've just pasted a thing in the chat, the 3D stainless steel printed bridge in Amsterdam as an example of it ain't all just plastic.
Yeah, but so basically for your home 3D printers, the basic material would be PLA, which is a a filament that comes into, it comes as a filament of one color, and that's plastic that will then be layered by the 3D printer to create these shapes. So you have, and most 3D printers today can accept, you've got different types of plastics. So the basic PLA is a fairly rigid plastic, but you've got other options which are less rigid, and that's your entry level option. If you look at other types of printing methods, then yes, you can have a whole variety of materials, as long as it can be as long as it can be laid out in layers, then a 3D printer would be able to deal, well, standard 3D printer would be able to deal with it. You now have more different types of 3D printer, like the resin printers, that use a different method, and that have different types of limitations, where in fact I'm not sure how they work really, but you've got a big resin and there's some sort of ultraviolet thing that goes into it and creates the shape. And
I think you have two beams coming opposite directions, and where they intersect, resin is laid out, comes out a solution, basically, some of them at least.
Yeah. So you've got a lot of, in the grand scheme of things, you've got a lot of different options. To do it at home, you've got a fair few options nowadays, but generally it's going to be PLA and PLA plastic, which PLA is a biodegradable plastic. You had another plastic which I forgot the name of.
ABS.
ABS, that's the one, which is not biodegradable, but it was easier to work with a few years ago. So nowadays all printers are able to use PLA. So that's what you would start with.
Thank you. That's very helpful. Thank you both.
Any more questions? If not, then we'll end it here. Thank you for coming,
Thanks.
and have a great weekend.